Welcome to another video. This is a limit problem, and it's been a while I've touched a limit problem on this channel. So let's just go back to Calculus 1. And this question was set in such a way that you are not allowed to use L'Hopital's rule. You're supposed to do algebraic manipulation or whatever else you know, but no differentiation. So we know that if we plug in x equals minus 1, in here we're going to get 1 plus minus 1, which is 0 on top and 0 under indeterminate form because we get 0 over 0. And if you can use L'Hopital's rule, you just take the derivative of the top and of the bottom, and you're going to get 9x on top. You get 13x under, plug in minus 1, you get at minus 9 over minus 13, and your answer is going to be 9 over 13. So with the knowledge of L'Hopital's rule, we know the answer to this is 9 over 13, but you're not allowed to use it. What would you do? This is one of the reasons I do not encourage L'Hopital's rule all the time unless you don't want to have fun. But if you want to have fun, there are other tricks you can use to simplify this. Let's get into the video. There's something you already know. You just don't know how good it is. It is how to factor the sum of two cubes. As you can see, this is the sum of two terms, and this term is odd. So let's recall. Recall that 1 plus x cubed can be written as 1 plus x times 1 minus x plus x squared. That's the factored form of this. And you can switch it, or you can write it this way. X cubed plus 1 equals x plus 1 times x squared minus x plus 1. The top and the bottom are exactly the same thing. Now, if you observe a pattern, you can build it up for forever. I actually worked on this and I saw that it always works. Now, if what we have here is not cube, if what we have here is x to the fifth, watch what's going to happen. If you have x to the fifth plus 1, what you're going to have here will be the same thing, x plus 1. But what's in the parenthesis is not going to start from x squared. It's going to start from 1 power below 5. So it's going to be x to the fourth. And the next sign will be minus x cubed. Followed, then you start this again. It's going to be plus x squared minus x plus 1. That is the factored form. So remember, the problem in this exercise is that x equals minus 1. And whenever you have x plus 1, this is going to give you 0, and then you have 0 on top, 0 under. But you can get rid of that by just factoring this. So you can already see that generally, x to the n plus 1 can be written as x plus 1 times x to the n minus 1 minus x to the n minus 2 plus you keep going until you get to x squared minus x plus 1. That is the general expression if n is odd. It does not work for even sums. The sum of two even terms, the sum of two terms like this, such that the exponent here is even, well, there's nothing you can do. You just have to let it be. But once it is odd, you can factor it this way. It works for the sum, it works for the difference. For the difference, I'm going to show you maybe in another video. Let's just focus on this one. For the difference, it's just going to be that instead of these being x plus 1, it's going to be x minus 1, and then you're going to have all positives on this side. Okay, so that's it. So we can say, therefore, the limit as x goes to minus 1 of x to the 9th, let me write it properly, plus 1 over x to the 13th plus 1 is the same thing as the limit as x goes to minus 1 of, this top part is going to be x plus 1 times, watch it, I'm going to start from x to the 8th. X to the 8th minus x to the 7th plus x to the 6th minus x to the 5th plus x to the 4th minus x cubed plus x squared minus x plus 1. That's a lot. Okay, I think I need to move this over to the side because I'm going to have to write 13 terms in the denominator in the other side here. X to the 9th plus x to the 8th minus x to the 7th plus x to the 6th. Well, I'm just going to have to do this. And then we have plus all the way to plus 1. Okay? It goes all the way until you get to 1, because that's the only way I can write all of that. So from here, we can tell that these two will cancel each other out. This cancels this. So what we have is now equal to the limit as x goes to minus 1 of x to the 8th minus x to the 7th. We're going to have 13 terms, x to the 12th minus x to the 11th plus x to the 10th, x to the 9th, x to the 8th plus minus x to the 7th plus x to the 6th minus x to the 5th plus x to the 4th, x cubed plus x squared. Let's finish this. Minus x plus 1. That's what we have under. Now we can plug in minus 1. Clearly, every time you plug in minus 1 into any of these even powers, you're going to get here, you're going to get 1, 1, 1, 1. And when you plug in minus 1 into the odd powers, you get minus 1. But minus 1 times minus is going to give you plus. So it's basically, this is equal to 1 plus 1 plus 1 plus 1 plus 1 plus 1. Come on, now I'm confused. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 1. You got 9 terms on top, and under you have 13 terms. So it's going to be 1 plus 1 plus 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that's the limit. So watch out for this type of expression. You can always factor them. And even what is inside can be further factored. You just have to do some grouping and you can break it into even smaller forms. Never stop learning. For those who stop learning, stop living. Bye-bye.